Welcome to the deep dive. Today, we're doing something a bit different. We're taking what looks like really technical stuff, practice questions for an IT exam, 400-007, and finding the big ideas, the aha moments inside. Think of it as tracing how our digital world actually works, how networks get smarter, safer, more responsive.
Exactly. And while the source is, exam questions, the concepts, they're fundamental. We're talking modern IT, networking, cybersecurity basics. So this deep dive, it's about pulling out those core principles. Useful if you're prepping for a meeting, taking the exam, or, just curious.
Right. And the source itself, 400-007 exam. Practice questions and explanations. Just for context, it mentions the exam is web-based. Pearson VUE delivers it.
Right.
You get 2 hours, 120 minutes for about 100 questions, all in English. But like we said, we're going way beyond just Q&A here. Should be a pretty interesting conversation, unpacking what these questions really tell us. Okay, let's jump right in. First concept, it comes from question 1, which asks, what is the primary purpose of a dynamically created tunnel interface in IPv6 multicast design? Now, multicast sounds technical maybe, but it's just about sending data efficiently to lots of people at once. Think TV broadcast versus individual emails. So for you listening, what do you think a dynamic tunnel is for in this setup?
The key answer here is first hop router registration to the RP, rendezvous point. Okay, so what does that mean? The RP, the rendezvous point, it's like the main switchboard for multicast traffic on a network. If a new source wants to broadcast, it needs to tell the switchboard it exists, that dynamic tunnel. That's how the first router, the one closest to the source, automatically registers with that central RP. It's crucial for setting up the path, making sure the data gets from the source to everyone who wants it. It enables the whole multicast routing thing to work properly, dynamically.
Okay, let's unpack this. Dynamically created elements. It sounds like the network is sort of organizing itself, like it's becoming more adaptive.
That's a great way to put it. Networks are definitely becoming more self-organizing. These dynamic processes, like the tunnel creation we just talked about, they allow the network to adapt to changes, automatically set up pathways without needing someone to manually configure every single step.
But does that self-organization, that dynamism, introduce its own, I don't know, complexities? Does it make it harder to maybe troubleshoot or control?
Oh, absolutely. That's the trade-off, isn't it? Dynamic behavior brings incredible flexibility and resilience. The network can often heal itself or find new routes on the fly. But yes, it can make things more complex to manage and visualize. If things are constantly changing, how do you track exactly what's happening? That's why you need, well, more sophisticated monitoring and orchestration tools to really get a handle on these dynamic systems. Flexibility versus complexity.
Interesting trade-off. Okay, so from moving data efficiently, let's switch to protecting it. Security is always huge. Our second question gets right into that, especially for hybrid cloud setups. It asks, in hybrid cloud computing, which practice best protects sensitive data in the private cloud? And that hybrid part is key, right? Your data might be partly on your own servers, partly in a public cloud. So what's the best way to lock it down?
The absolute best practice, the non-negotiable one is encrypt data both at rest and in transit. Yeah, you really have to do both. At rest means when the data is just sitting there on a hard drive in a database. In transit means when it's moving across the network, maybe going from your private system to the public cloud, or even just between servers internally. Encrypting it in both states ensures it's scrambled, unreadable to anyone who shouldn't see it, whether they intercept it moving or somehow access where it's stored. It's fundamental. Data is either sitting or moving. You got to protect both phases.
Right, makes sense. So connecting this to the bigger picture, what does this mean for us, regular users interacting with cloud services every day, storing photos, banking online? What should we be aware of or maybe look for?
Well, for us as users, it means we should probably favor services that are transparent about their security. The ones that talk about using strong encryption. We can't usually verify how they encrypt, but knowing that reputable services do encrypt data at rest and in transit gives you a baseline level of confidence. Look for terms like end-to-end encryption or mentions of robust security protocols. It tells you they're thinking beyond just a simple password. They're protecting the data itself, wherever it is.
Got it. Okay, so we've covered moving data and protecting it. Now, how about managing these massive networks, especially wide area networks, WANs connecting lots of sites? That brings us to SD-WAN. Question 3 asks, which feature of SD-WAN simplifies network management and policy enforcement? Managing hundreds of branches used to be a real headache, right? So what's SD-WAN's big innovation here?
The game-changing feature is centralized orchestration and control. Yeah, this is a huge shift. Think about the old way managing maybe hundreds of routers individually, logging into each one, typing commands. Tedious. error-prone. SD-WAN brings it all together. Centralized orchestration means network admins use one interface, one platform to define policies and push configurations out everywhere. It simplifies management massively, allows for automation, ensures policies are consistent across the board. It's like having a central brain for the entire wide area network.
That centralization sounds incredibly efficient. It almost feels like, well, a paradigm shift from that old fragmented way.
It absolutely is. What's fascinating here is how it moves network management from a device-by-device task to a system-level, policy-driven approach.
Yeah.
This leads to much greater agility. You can roll out changes way faster and fewer errors because you're not relying on manual config on every single box.
So what does this mean for businesses relying on these networks? What kind of aha moment does this feature provide them?
The aha moment is realizing your network can finally keep pace with the business. Need a new application prioritized. Need to set up a new branch securely. With centralized control, you can do that quickly and consistently, rather than it being a months-long project involving touching dozens or hundreds of devices. It means the network becomes an enabler, not a bottleneck.
All right, let's shift gears again to a security concept that's really been gaining ground, zero trust. Question 4 asks, what is a fundamental concept of zero trust security architecture? The name itself, zero trust, is pretty bold. What does that imply to you? What should we think when we hear that?
It implies exactly what it says. Trust nothing by default. The fundamental concept is authenticate and authorize every access request continuously. And this is a huge departure from older models. Traditionally, security was like a castle wall. Once you were inside, you were generally trusted. Zero trust throws that out. It assumes any user, any device, anywhere could be compromised. So it doesn't matter if you're inside the office network or outside. Every single time you try to access something, a file, an application, a server, your identity and permissions need to be verified. And not just once, but continuously. It drastically reduces the attack surface.
Continuously verifying every access. That sounds intensive. This raises an important question, doesn't it? How does this model fundamentally change things from just having a strong firewall?
It completely shifts the focus. Perimeter security, like firewalls, is about keeping bad actors out. Zero trust assumes they might already be in, or that a trusted user's account might be compromised. So security moves from the edge, the perimeter, to protecting individual resources and verifying every single interaction. It's about least privilege access, constantly validated. Crucial in today's world where the perimeter is basically gone, with cloud services and remote work.
Okay, that makes sense conceptually. Can you give us a real-world analogy, something to help really grasp never trust, always verify?
Sure. Think about maybe a high-security government building or even a modern airport. In the old model, maybe you showed your ID once at the main entrance and then could wander around relatively freely inside. Zero trust is like needing your ID and specific clearance badge checked at every single door inside that building, the door to your specific office, the door to the cafeteria, the door to the server room. Even if you just came from another checked area, you get checked again for that specific access. Always verifying you are who you say you are and that you have permission for exactly what you're trying to do right now.
That's a great analogy. Okay, final concept. Let's talk about monitoring these huge, complex networks we've been discussing. How do you keep an eye on performance? Question 5 asks, which telemetry method is best suited for scalable, real-time monitoring in large networks? The challenge is getting immediate insight, right? Not just checking every 5 minutes, but getting a sort of live feed.
Exactly. And the best method for that scalable real-time view is streaming telemetry using model-driven data. Okay, let's break that down. Traditional methods like SNMP polling are like asking the network, how are you, every few minutes. You get snapshots, but you miss things happening between polls. CLI checks are even slower, more manual. Streaming telemetry is different. The network devices push data out continuously in real time as things happen. And the model-driven part means the data is structured, consistent, like using standard labels. This makes it much easier for automated tools to ingest and analyze that constant stream of information very quickly.
So it's a move from those periodic snapshots to more like a live video feed of the network's health.
Precisely. You get much finer granularity and faster detection. Instead of finding out about a problem minutes or hours later from an old snapshot or log file, you can see anomalies developing almost instantly.
Here's where it gets really interesting. How does having this real-time data actually change things on the ground? For problem solving, for optimizing the network?
Oh, it's transformative. For problem solving, you shift from being reactive scrambling after something breaks to being proactive. You can see performance degrading or errors starting to spike before it causes a major outage. You can pinpoint issues much faster because you have that continuous data stream leading up to the event. And for optimization, You get incredibly rich data to see exactly where bottlenecks are, how resources are being used, allowing for much smarter, data-driven decisions to fine-tune performance and capacity planning. It's about intelligence, not just monitoring.
Wow. Well, thank you for joining us and sharing your insights on this deep dive. It's been fascinating.
My pleasure. And maybe something for everyone to think about. Considering how fast all this is changing, network, security, monitoring, how might these same principles, this need for dynamic adaptation, constant verification, real-time data, how might that change our expectations in other complex systems? Think
Yeah.
smart cities, supply chains, maybe even other areas of life. Where else will we demand this level of responsiveness and verifiable trust?